Okay, this is lesson 45 for Algebra 2. We're going to write and graph linear inequalities. The goal for today, or the objective, students will write and graph linear inequalities. These are the steps. By writing the steps down, or you should have them down already. But this is a review from Algebra 1. We're gonna just do compound inequalities today also, which is kind of Algebra 2 level. So it's a little bit more difficult. Still, Algebra 1 concept, we're just making it a little bit more difficult. Okay, so you should already know a lot of what we're gonna do today. Here we go. Number 1. Just watch me do number 1 and 2. It'll make sense after I do it. Okay, number 1. So we have an inequality. We know it's an inequality because there's an inequality sign. It's less than or equal to. So we're trying to solve for a. We want a by itself. So the way we do this is you combine like terms first. So what I'm going to do here first is multiply 5 times 5 is 25. I'm going to bring that down under here. 5 times negative 4a is going to be negative 20a. Bring the rest of the problem down, less than or equal to 145. Okay, then I want a by itself. So I'm going to use this thing called SADMAP, which is just backwards orders of operations. I want to solve for a, so I use backwards orders of operations to solve for a. So SADMAP is what I call it, but ask myself, are there any subtraction signs by the a? No, there isn't any subtraction signs. This is negative 20 times a, so we don't have any. Any addition signs? Yeah, there's an addition sign here. It's plus 25, so I want to get rid of this plus 25, so I'm going to subtract 25 from both sides. I'm doing the opposite of plus 25. What's the opposite of plus 25? Subtract 25. We're trying to isolate a, okay? Okay, and then we ask ourselves, are there any division signs to deal with? No, there aren't any division signs. Any multiplication signs? Yeah, this is negative 20 times a. So I'm going to do the opposite of multiplying by negative 20. I'm going to divide by negative 20 on both sides. When I divide by negative when I'm dealing with inequalities, look at this carefully. It says less than or equal to. When I divide or multiply by negative, I'm going to change the inequality sign to greater than, or do the opposite. So we got 120 divided by negative 20 is negative 6, and then negative 20 divided by negative 20 is we just cancel out, leaving just a. When I have an inequality by itself, I want the a to be first. So I use the symmetric property, put negative 6 on the opposite side, and look carefully. Since I'm switching the sides, the inequality sign needs to switch one more time back to less than or equal to. Okay, this would leave an accurate answer. So a is less than or equal to negative 6. So then I go to negative 6 on my number line, plot my circle. I ask myself, is it going to be filled or not? I know if it's going to be filled if there's an equal sign right here. So since there's an equal sign, I'm going to fill in my circle and my answer at the top there. And then since it says less than, I'm going to make my line go left. I'm going to have an arrow going left. Okay? So we have the answer written as follows, okay? Again, all I did was I solved for a. This is an Algebra 1 concept, solving for a, all the way through, back to a is less than negative 6, okay? I use this backwards orders of operations to solve for a, okay? Watch me do number 2. Number 2 is a little bit more complex now. This is a compound inequality. So I'm going to rewrite it actually so you can see it. So you got 44. Is greater than or equal to 8 minus 12x, which is greater than negative 52. Okay? So the first thing I notice is that there's two inequalities. There's an inequality sign here, and there's one over here. The x is in the middle. So x is already the x is already isolated somewhat, but it still needs to be isolated some more. There's an 8, a positive 8, and then the negative 12 is being multiplied into it. So I look at SADMAP again. Are there any subtraction signs by the x? No. This is a multiply sign. Any addition signs? Yeah, there's a plus 8. So I'm going to subtract 8 from the middle. Watch carefully what I do now. I'm subtracting 8 here, so I have to do it on all parts of the inequality. I'm going to subtract 8 on the outside of the left side and the right side of the other inequality. Subtracting 8 on these three sections. Okay? So, continuing, 44 minus 8 is 36. Is greater than or equal to. 8's cancel out. We have negative 12x, which is greater than. Negative 52 minus 8 is negative 60. Then I'm going to ask myself, are there any division signs? No. Multiply sign, yeah, there's a negative 12 multiplied by the x, so I'm going to divide both sides, or all sides, by negative 12. So, dividing this by negative 12, and this by negative 12. Okay, when I divide by a negative sign again, I'm going to flip my inequalities, so this inequality and this inequality here are both going to be flipped now. So instead of less than or greater than or equal to, it's going to be less than or equal to, and the other one's going to be less than. So we get 36 divided by negative 12 is negative 3, x in the middle, and then we have negative 60 divided by negative 12 is 5. And that's it. Now x is by itself. This is our answer. So we know that x is greater than or equal to negative 3. So I'm looking at this backwards. This is a less than or equal to sign, but it's going to be greater than or equal to negative 3. And x is also going to be less than 5. So now I'm going to plot these points. I'll start with 5, okay? Plot a point at 5, or plot a circle there. It doesn't have an equal sign, so I don't fill it in, and we know x is less than 5. So I'm going to kind of start my line going left, okay? Now, the other one is at negative 3. So I plot a circle at negative 3. And this one is going to be filled because it includes an equal to sign. And we have to look at this differently. It says negative 3 is less than or equal to x, right? But x is also greater than negative 3. If negative 3 is less than, then we know x is greater than negative 3. Another way you could look at this is you could say x is, just flip the sign, put x is greater than or equal to negative 3. You don't have to do this, but this is the way you could see it. So you go to negative 3. If it's greater than, it's going to the right. So then you know that these two lines will be touching, okay? So you know that that your solution will look like this. And what this is saying is that any number or any point on this number line from negative 3 all the way to positive 5, but it doesn't include positive 5, will be a solution to this inequality. That's what that's saying. Okay? So raise your hand if you've seen this before somewhat in Algebra 1. Okay, good. So this is our review. The only thing that's more difficult for Algebra 2 level is just that it's a compound inequality. Okay? So, what I'd like you to do... From here? Yeah. To where? Here? Yeah. Oh, I was just explaining that if this confuses you, that x is greater than negative 3, another way you could do it is move the x here, put the negative 3 here, that way you know, and then flip the sign, because you want the opening sign to x, that way you know x is greater than negative 3. I just rewrote it so that you could see it. You do not need to put that there. You could just go straight for it. Okay? Alright, so the two things, you need to have a solution and graph. That's the goal for tonight. Why do I fill it in? I fill it in when it says equal to. You see it says equal to? This one doesn't have equal to, so you keep it open. Does that make sense? The first one was equal to. It said less than or equal to. Okay? So, again, 1 solid 2 is about number 1. 2 solid 1 is about number 2. Ready, set, and go. So again, you're starting on number 3, and I want you to give me the answer. Don't show me the graph yet. If you want to graph it, that's fine. But I want to make sure your answer is right before you graph. Okay, so the first thing, you could distribute. I showed you how to distribute last time. I'm going to do it differently. Watch this carefully. This is like saying 6 times this quantity. Another way you could have done it is just divide both sides by 6 in the front. So we got negative 12 is greater than or equal to v minus 6. Add 6 to both sides. You got negative 6 is greater than or equal to v, or v is less than or equal to negative 6. So if you made a mistake, please fix it. And then let's graph it now together on your whiteboards. You can flip it around or you can make your own number line. That's fine. So start with negative 6 and it's going to be filled and pointing to the left. Okay? Number four, ready? And go. Now, number 4 is a compound one, so this one's going to be very similar to number 2, okay? So in this example, here we go.
Really don't. Why do you flip it? Because of the M square. Oh yeah. What did you say? Turn it. That's what I did. Come on, Carrie.
Okay, so I just showed you how to do this one, and then if you're going to graph it, let's check your neighbor's work right now for the graph. Aaron's checking their neighbor's work. I'm going to graph mine on the board, check yours against mine and your neighbor's. You've got 8 and 11, and these are both going to be filled in. And they are pointing, it's going to be 8, m is greater than 8 and less than 11, so it's going to be pointing toward in the middle, okay? So it's included. All right, so give me raise your hand if your neighbor got it correct. Raise your hand if your neighbor got it correct. Okay, good. Next, number 5. Now, number 5. Everyone, all eyes up on the board, please. Okay, now number 5. Listen, hey. Okay, there are 2 inequalities on number 5, so you have to do them separately now. We don't do the same operation on both. So you really have 2 inequalities that are separated by or. So all you do is 2 separate problems on number. Okay, so we start by looking at the first inequality. We have 10 minus 8b is less than or equal to negative 62. So just solve it as its own inequality. So I'm going to subtract 10 on both sides. So we got negative 8b is less than or equal to negative 72. Divide both sides by negative 8. When you divide by negative, we're going to flip the sign, so it's going to be b is greater than or equal to 9. So that's your first answer. Now we're doing the second one. So we got negative 3b minus 8 is greater than or equal to negative 11. So add 8 to both sides. We have negative 3b is greater than or equal to negative 3. Divide both sides by negative 3. We're dividing by negative, so we have to flip the inequality sign again. So we got b is less than or equal to 1. Now there's 2 different answers. So if you were to graph both of these on your graph down here, let's start with this one. B is greater than 9 or equal to 9. You're going to draw a circle at 9 and you fill it in. And it says it's greater than, so the arrow's pointing to the right. Okay? Now look at this one. B is less than or equal to 1. This one also is filled in, but this arrow is going to the left. Are they crossing over each other? No. So on this answer, since they're not crossing over each other, they're not it's not in a union, so you have to put that the answer is b is greater than or equal to 9, or you put the word or in the middle, or b is less than or equal to 1. Okay? That makes sense? So, turn to your neighbor. Talk about how this one is presented differently, how you have to do 2 separate problems. and that the answers are not crossing, so you have to put the word or in there. Ready, set, go.